Hello, this video is going to look at 12E, which is where we're looking at finding a feasible region. So we had another video which was looking at this graph here, which is how we actually drew these two lines. What we're actually looking for now in this video is finding the intercept where these two lines meet. We want to know those coordinates, and that's doing it manually using simultaneous equations. I believe this should be revision for you from chapter 3, but just in case, I thought we can go through how to do these simultaneous equations in two different ways and use the way that you prefer. As long as you're getting an answer at the end that is along the right track, then you're doing okay. So the first way that we can use it is via elimination. So if we're using elimination, what we use is our two equations, and 6x plus 4y is equal to 36. Now if we look at these values here, we have an x up here and 6x here, so 6 times this original x. We have 2 y's here and we have 4 y's here. Now I'm going to eliminate the y value out of one of these equations, and the way I'm going to do that is by timesing this whole equation by 2. The reason I do that is that we then get 2x, oh, sorry guys, my hand slipped on the page, 2x plus 2 times y, so 2y times 2, 4y is equal to 10 times 2, 20. Now what we are going to do is we are going to eliminate it from the first equation, or rather from the second equation. So we're actually going to minus away this value, this equation, from this one. So all we need to do is actually combine the two equations. So our equation becomes 6x minus 2x plus 4y minus 2y, which is equal to 36 minus, that should be a 0, 20. So now our resulting equation will be that the 4y, that should be a 4y, pardon me, the two 4y's that are here, they actually cancel it out. Plus positive 4y minus 4y, these two will cancel out. We're left with an equation that says 4x, right, 6 minus 2, 4x equal to 36 minus 20, 16. Then what we can do, we want the x value by itself, so we divide by 4, we divide by 4. X is then equal to 4. So we've just solved for x. We've just found what x is, our x coordinate. So we now know that our final coordinate will contain 4 as the first number. Now what we need to do is substitute it back in to our first equation so that we can find out what y would be. So if x is equal to 4, we're actually going to move this value, this 4 value, and place it in this equation. So the way we'll do that, line to separate, we say 6 times 4 plus 4y is equal to 36. We know that 6 times 4 is 24, plus 4y is 36. Oops, sorry. So we will minus 24 from this side, minus 24 from the other side, and we are left with 4y is equal to 36 minus 24, 12. We want to get y by itself. Divide both sides by 4. Y is equal to 3. So now we know both of our coordinates. So we know that if y is equal to 3, our second coordinate is 3. Looking at these two, they make a full coordinate. So 4, 3, 4, 3. There are x and y values. So that's one way we can find this intersection point. Okay, whereas if you do look at it on our graph here, you can see that it pretty much lines up. So if you count across 4 and go up, and we go up 3, you'll actually reach that intersection point. So this is how we can algebraically figure it out. Now the other way that we can do it is by looking at substitution. So the way that we solve for substitution is again using these two equations. So x plus 2y is equal to 10. We're actually going to convert that equation. We're going to rearrange it. We'll make x the subject, and that it's equal to 10 minus 2y. Our second equation, which is 6x plus 4y is equal to 36, we are going to place this x value into this equation. We're going to substitute it in. That's why it's called substitution. What we end up with is 6 times 10 minus 2y. So all we've done is taken this 10 minus 2y, which we've said is equal to x, and put it in the place of this x. That's the only thing that we've done. 10 minus 2y, we finish the equation, plus 4y. If I can draw my 6's, that's a terrible 6, but 36. Now we expand the brackets. So 6 times 10, 60, minus 6 times 2y, 12y, plus 4y is 36. We can now simplify this even more, and we can say 60 minus 8y, we've just added these two together, is equal to 36. Now we want to get rid of this 60 from this side, so we're going to minus another 60, minus 60 from the other side. Make sure you can see the bottom of the page here. And we end up with minus 8y is equal to 36 minus 60 is negative 24. Again, we want the y value by itself. So if we divide by negative 8, and we divide this side by negative 8, y is then equal to 3. And we have just found the same y value as what we did when we used elimination. Same y value. And here as well. So we've found the y value. So now we need to find our x value. How we do that is we solve for x. So we know that y is now equal to 3. So we solve for x when y is equal to 3. So we take our original equation, which was x plus 2y is equal to 10. We know what y is now. We know that y is equal to 3. So we can say x plus 2 times 3 is equal to 10. We know 2 times 3 is 6. So we're saying x plus 6 is equal to 10. Now we want to remove the 6 from this side. So what we need to do is move it to the other side. And our final answer for x, and once we've cancelled these out by the way, These will cancel out. Therefore, x is then equal to 4. So we have, again, the same coordinates. So our final coordinates will then be 4, 3. That's how we find every single point along in this graph. So there are a few points that you need to find. You need to find your intercepts, and then you also need to find where they intersect, both of these inequalities, when they're drawn as a line. Make sure you shade in your feasible region as well and indicate what that feasible region is of.